Welcome to our electrical engineering YouTube channel. In this video, we will see an example on equivalent resistance. To download our electrical engineering app, you can visit this website link electrical-engineering.app. This website is especially designed for electrical and electronics engineering students. Question: find equivalent resistance between terminals A and B. Now here for this network we have to determine its equivalent resistance between terminal A and B. Solution: first of all we will take this circuit. Now here we can see we have to determine the equivalent resistance between terminal A and B, and here we can see all the resistances have same resistance R. So here we can apply principle of symmetry. So before that we will apply a voltage source between terminal A and B. Let's say we apply voltage V. Now what will happen? There will be a current flow I. Let's say the current through this network is current I, and this current will be same current I. Now we know that according to KCL, that is Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here at this node, let's say the current is entering I. So let's say this current is I1, this current is I2, and this current is I3. So now what will happen? I is equal to I1 plus I2 plus I3. So instead of writing I1, I2 and I3, since the circuit is symmetrical, so what will happen? Same current will flow through this terminal or this resistance between A and C, and same current will flow between A and O, and same current will flow between A and D. So here we can write, instead of I1 we can write I divided by 3. So here this will be I divided by 3, this will be I divided by 3, and this will be I divided by 3. Now next what will happen? This I1 will go through this. Now here this C and this D, it is short circuited, so it is the same node. And also this E and F, this is also the same node. Now here this I1 will flow through this and then go to this resistance between C and O, and similarly the current, some current will flow between C and E. Now similarly this I3 will go to this resistance between D and O, and it will go between D and F. Now what will happen? This is a symmetrical circuit, so the same current will flow between C and E, and here also the current between D and F will be same. Similarly, the current between C and O will be same, and the current between D and O will be same. So because of that, what will happen? There will be this node voltage will be 0. So here we can write VO is equal to 0. Now if this VO is equal to 0, that means we can remove this part. So let's see how we can remove this part. So if we erase this thing, or if we bypass the current like this, then there will be no effect on resistance. So here it will be like this. Let's take white color. Now also the circuit will remain same, because no current will flow between this O, because it have 0 voltage. Now the current can directly flow from A to B. Here we can see the current I2 can directly flow from A to B. Now we can easily simplify this circuit. So again, let's copy this circuit from here. And now here we can see this R and this R connected in series. So it will be R plus R 2R. So let's solve this. It will be simply 2R. It will be 2R. Now here also this R and this R connected in series. So again it will be same. It will be 2R. It will be 2R. Now again here we can see this R and this 2R are connected in parallel. So R parallel with 2R, it will be R into 2R divided by R plus 2R. Now if we simplify this, it will be 2 into R square divided by 3R. So it will be simply 2 by 3 R, because this square will get cancelled with this R. So it will be simply 2 by 3 into R. So now again, let's copy this circuit from here. Now it will be simply 2 by 3 R. We can erase this resistance. And we can also erase this resistance because both are same. So now this will be 2 by 3 R and this will be 2 by 3 R. Now next, here we can see this R and this R, they are connected in series. So let's simplify them. Let's copy this circuit first, because we are solving step by step. So now this R and this R, they are connected in series. So it will be simply 2R. Now this will be 2R. Now here this is not a joint, this is a jumper. Now next step, here we can see this C and this D, they are connected together. That means this R and this R, they are connected in parallel. So again, let's copy this circuit from here and paste it. So now if we solve this R parallel with this R, it will be a single resistance of, now R parallel with R, it will be simply R into R divided by R plus R. So it will be R square divided by 2R. So it will be simply 1 by 2 R. Now we can replace these two resistances with a single resistance of 1 by 2 R. So again, let's copy it. We can erase any one of them. So let's erase this one. Now this will be simply 1 by 2 into R. Now here also we can erase this one. Now it will be simply 1 by 2 R. 1 by 2 into R. Now next, here we can see this 2 by 3 R and this 2 by 3 R, they are connected in parallel. So let's solve this. Let's copy this circuit from here first. Now 2 by 3 R parallel with 2 by 3 R. It will be simply we have to take the half of it. So let's solve this step by step. So 2 by 3 R multiplied with 2 by 3 R divided by 2 by 3 R plus 2 by 3 R. So this will be 2 by 3 into 2 by 3 is it will be simply 4 by 6, or let's solve this in calculator. 2 by 3 into 2 by 3, it will be 4 by 9, sorry. So it will be 4 by 9. 4 by 9 R divided by, now this 2 by 3 plus 2 by 3, it will be 4 by 6. 4 by 6 R. Now this R and this R will get cancelled. Now here this will be R square. So now this will be 4 by 9 divided by 4 by 6. 4 by 9 divided by 4 by 6. It will be 2 by 3. So 2 by 3 into R. This R and this R square will get cancelled. So now the circuit will look like this. We can erase this resistance and it will be replaced by simply 2 by 3 R. Now here there is a slight mistake. This will be 4 by 3. So it will be 4 by 3 and this will be, now if we divide 4 by 3, if we divide 4 by 9 with 4 by 3, it will be 1 by 3. So now it will be 1 by 3. So now we can replace these two resistances with 1 by 3. So let's replace them. It will be simply 1 by 3 into R. Now we can easily simplify this. So this 1 by 2 R, 1 by 3 and 1 by 2, they are connected in series. So it will be 1 by 2 R plus 1 by 3 R plus 1 by 2 R. It is equal to, let's solve this. So 1 by 2 plus 1 by 3 plus 1 by 2. It will be 4 by 3 R. 4 divided by 3 into R. Now again let's copy this circuit from here. Now we are solving this circuit by step. So we can erase this resistance and this resistance, and this will be simply 4 by 3. 4 by 3 into R. Now here we can clearly see this 2R and this 4 by 3R, they are connected in parallel. So 2R parallel with 4 by 3. 4 by 3 into R. It will be 2R multiplied with 4 by 3R divided by 2R plus 4 by 3 R. Now if we solve this in calculator, it will be 2 into 4 by 3, it will be 8 by 3. 8 by 3 R square divided by, now here this will be 2 into 3. Let's solve this in calculator. 2 plus 4 by 3. So it is 10 by 3. 10 by 3 into R. So therefore our final answer for RAB will be, this R and this R square will get cancelled. So 8 divided by 3 upon 10 divided by 3. So it is 4 by 5 into R. So this is the final answer for this problem. If you want to download notes, you can visit this website link, electrical-engineering.app. Don't forget to like, share and subscribe to this channel, and thanks for watching.